This is a severe weather analysis for January 10th, 2020. The Storm Prediction Center has a moderate risk of severe weather across parts of the Arklatex into southeastern Oklahoma. This is mainly wind driven, but also includes potential for very large hail in some areas and tornadoes. Looking at the HRF version 2 forecast, we're going to be seeing the thermodynamic environment, which is going to be characterized mainly by low level moisture advection as a surface low develops and intensifies. This is going to be occurring right around in here in northern Texas and progressing into the Ozarks later during the period, as we see here by this Weather Prediction Center map. And that's also going to be the driving factor for low-level forcing, because we have a stationary boundary initially, but as the cyclone develops and translates eastward, we have a push to that baroclinic boundary, and that develops into a cold front, and that's going to be forcing convection to progress into the moderate risk area during the overnight hours. The thermodynamic environment is characterized mostly by moisture advection and cold air aloft, leading to steep lapse rates. Now, the moisture advection is a big factor to this, because low-level jet increasing with the deepening of the cyclone pressure falls will facilitate the development of the movement of moisture that is significantly above normal. P-water anomalies, precipitable water anomalies, are currently, from the GFS, 1 inch above normal in this region, and could exceed values of 1.7 inches in some of these areas. That's going to be a considerable factor. But looking at this through the late afternoon and into the overnight hours, we see that this area right here tends to be favored for modest CAPE. We're looking at values between 750 and maybe 1,500 joules per kilogram. That's going to be because mainly we have a kind of warm sector that's not particularly unstable. We've got a little bit of inhibition during the afternoon, and we've got some cloudiness, and we've got some rain because of the increasing upper level dynamics. But we do have enough moisture advection and heating to compensate for that and produce severe weather that is, or produce an environment that is conducive to severe weather. And that's going to be mainly driven by this significant shortwave trough that is intensifying and amplifying over the central and southern plains, ejecting into the region with intense upper level jet stream dynamics given by this here strong divergence and effluence in the mid and upper levels, along with the intensification of flow magnitude for the area. But an interesting thing is that when we look at the 850 millibar upward vertical velocity, this is roughly going to represent where convection is developing along the line, the stationary boundary that transitions to a cold front. Looking at the orientation of this, we see it's oriented about like this. And going over to this map here, we see that deep layer wind vectors are oriented roughly parallel to that. And that indicates a situation usually favorable for primarily linear convective development. But we do have another thing to consider about this. With pressure falls and the attendant increase in radial inflow into the cyclone, we will have subsequently a strong low-level jet developing. And we see here by the rapid refresh model, this only goes to 02Z, but this will continue into the overnight hours, well after 00Z, and into the next forecast period, in fact. But here we see 850 millibar flow that is reaching 50 to 60 knots in this region, and that's going to lead to a lot of low-level wind shear and a tendency, even in linear convection, for mesovortices and localized areas of enhanced tornado and damaging wind potential to develop. We'll look at a forecast sounding here in a moment to illustrate that. But another interesting thing in the thermodynamic environment, this is 03Z from the GFS, or actually the NAM, for 7 to 500 millibar lapse rates. This area here, which is in the warm sector, is showing lapse rates of between 6.8 and 7.3 degrees Celsius per kilometer, and that is pretty unusual to find in this kind of environment, and indicates further instability, not only in low levels due to the buoyancy added by moisture advection, but also for the increase in thermodynamic instability aloft by the cold air moving into the region and the attendant increase in the steepness of lapse rates. And we're going to look at this model here, the forecast sounding. We're going to take this from around northwestern Louisiana. This is well within the moderate risk area. The first thing we'll notice is the strong curvature and length of the hydrograph for the 0 to 3 kilometer layer. We'll also notice the deep instability and the positive area that is still represented into the overnight hours by the sounding. And that is going to be combined with the shear, like I was just talking about. We'll take a look at this here from the HRF version 2. For both effective layer and fixed layer shear values, we're going to have very large values of storm relative velocity given by this model we see here. This is in the afternoon hours. They're pretty mild, but they're getting stronger. And then during the overnight hours, we see values over the Arclitex in the moderate risk area really ramp up to over 400 meters squared per second squared. That's going to lead to a lot of wind shear and a tendency, like I said, for isolated mesovortices along the quasi-linear convective system, QLCS. Lastly, we're going to take a look at the simulated reflectivity from the HRF version 2, the 00Z run from this evening. It's early morning actually now. The HRRR, and we see what I was talking about earlier, kind of suggesting there could be some rain ahead of the thunderstorms, but don't let your guard down. That is not an indicator that storms will not form, because we see, according to this model, when it decides to run, during the afternoon we have convection developing in the southern plains, Texas, Oklahoma, and that develops further, initially along the stationary boundary, into a very expansive and strong quasi-linear convective system that progresses into Louisiana and Arkansas during the overnight hours. Because these thunderstorms will develop along the stationary boundary initially, I would expect for some training and very heavy rain and flash flooding potential in Oklahoma and Texas with the initial development, before we get a little bit of forward movement in them with the acceleration of the cold front. Thank you, Windows. And we see here localized pockets of enhanced updraft helicity, which will represent for us the localized potential for enhanced damaging winds and even isolated tornadoes. Some of the tornadoes could be strong, especially if a discrete storm happens to develop ahead of the line. Also, isolated severe weather potential up here into Kansas and Missouri. Now, this is a really dynamic system, and I know that I'm only addressing the severe weather side of this. There's going to be a lot of ice up here in Michigan, a lot of snow in this region, and in the cold sector of the cyclone, but this is focused on the severe weather potential. This has been a severe weather analysis for January 10th, 2020.